Section 7.4 talks about solving nonlinear system of equations, which just means that one of the equations is not a line. So for example, this one is a line. This one actually graphs a parabola. So we look at where they intersect, if you think about graphically. To solve for the substitution method, what you want to do is take one of the equations and solve one of the variables. So I took this first equation, and I decided to solve for y. You could also solve for x if you choose, but I decided to solve for y. So I subtracted x from each side. And then what I want to do is plug this in for y into the other equation. So that's what I put right here. So instead of y, over here, I put 2 minus x. At this point, I want to go ahead and solve it. So I want to have a 0 on the one side. So I add an x, which gives me negative 5x, and I subtract 2, which gives me 6. So now we have a quadratic equation. You can either use a quadratic formula, or this one does factor nicely, so I went ahead and factored it. So one answer I got for x is 4. The other answer I got was 1. Okay. Each of these will correspond to an different ordered pair. So just think about this is a parabola and a line where they're intersecting, so it could intersect at 2 different places. Okay, now I want to find the other value of the ordered pair. So using this equation right here, I first plug in 4 to see what that ordered pair was, and then I plug in 1 to see what the other ordered pair is. So if I plug in 4, you can see you get y is negative 2, that's one ordered pair. If I plug in 1, I get 1. So this is my 2 ordered pair that satisfies this system of equations. So again, this is where a parabola and a line intersect.